Welcome to Eaton's 10 in 10 podcast, where we focus on industry trends shaping the future of power management. In this series, our expert answers 10 questions about one of today's most talked about industry topics in 10 minutes or less. From the energy transition to digital transformation and beyond, we explore trends and discuss strategies for delivering safer, more efficient, and reliable power.
Hi, I'm Tony Trim, one of the solution architects for the Brightlayer Industrial Suite, here with another Eaton 10 in 10 podcast. Most of us are familiar with the term Industry 4.0, but there are common fears and misconceptions about what it means at a practical level. Today I'm talking with one of my colleagues, Alejandro Barreto, another solution architect, about the realities of implementing Industry 4.0 in industrial facilities. We've got 10 questions lined up and 10 minutes to answer them. Alejandro, thanks for joining me. Let's get started.
Thank you, Tony.
It could be difficult to connect the idea of Industry 4.0 to your facility and day-to-day operations. Can you tell me what are the advantages for a facility with no smart devices?
It's always important to have a blueprint or a roadmap that we consider things like scalability, cybersecurity, CapEx and OpEx cost, training, and change management that are involved. That said, for a facility coming from a primary analog environment, start by defining opportunities for an easy win or quick time to value to use as a proof of concept to demonstrate the benefits. It could be a system providing notifications of smart alarms or interfacing with existing equipment to bring the information to operations and maintenance. Just keep it simple and bounded.
So we've just addressed a facility with no smart devices. So what if you already have deployed some smart devices in your operations?
Well, even in locations where you have deployed devices, many new sensors and instruments are equipped with diagnostic, health, and performance indicators that can be used to provide warnings and prevent failures and downtime. As you deploy additional field devices, communications, and infrastructure, you can enhance the understanding of your equipment and operations, using data from your equipment and analytics within your software solution to drive decisions to actions. As you continue to capture data, it can be used to develop digital twins, augmented reality, and other visualization techniques which provide insights to drive efficiency and reliability, which is a second step from the basic development. Even when you have a site with PLCs, a DCS system, historians, and control systems, you most likely will find stranded data or devices that were not part of the existing control system from which you can gather information and valorize that data.
Okay, that's great. So there's a lot of confusion around the software as a service model versus purchasing a solution. Why would you choose one or the other?
Well, many products, including software, have shifted to the as-a-service model, a subscription rather than a software purchase. And there are a number of notable benefits to the subscription model. I can mention a few of them, which could be provide access to a technological infrastructure with a low entry cost. And this is important. Upfront CapEx spend is reduced and is spread over a predictable and consistent OpEx spend year after year, which align with the lifetime of your assets and critical equipment. When you subscribe, your software provider is responsible for maintaining and upgrading the system rather than your IT/OT departments. And because these systems are cloud-based, disaster recovery most likely will take a fraction of the effort compared with recovery with an on-premise solution.
People often struggle to put a dollar value on data. Can you possibly walk through the value of capturing data and when can a user expect to see return on their investment?
I would say that there are many ways that data can be used to save money and time, which amounts to the same thing in business. And let me just mention one of the most common, which will be preventing unplanned equipment failure. Any downtime includes the cost of lost production as well as the cost of reallocating resources, which can be in the thousands of dollars per hour depending on each particular application. There is also cost related with equipment repair and replacement cost. Some examples that I can mention on this are well known, like vibration analysis on motors and actuators, environmental conditions like temperature and humidity leading to corrosion in electrical gears, monitoring of circuit breaker health and status can serve as a predictive maintenance. So there are many applications that can be used to calculate an ROI.
Great segue into predictive maintenance. So my next question has to kind of do with the premise of that. So what are the main advantages of using the cloud?
The cloud allows users to access many resources that will not be easily available otherwise. And this is due to cost, complexity, or what we need to put together. Data access points are typically predefined or pre-configured, such as data servers, dashboards, and portals. The cloud also allows access to applications like artificial intelligence or machine learning by paying for the time and resources to match the user's requirements. Pay for each application as you need it, pay for the storage as you need it, rather than building your own data center. Expand the storage as you need it or with a request or a click of a button. Access to the cloud is also configurable and available from anywhere. No need for a VPN and local security management. This is taken care by the cloud service provider, not by the user.
So Alejandro, can you give some examples of these?
Well, similar to what I mentioned before about the unplanned downtime, I would say that optimizing operation through data analysis, pattern recognition, classification, adaptive techniques, this is to put the data into context and to gain insights that can be converted to actions. These tools, the artificial intelligence and machine learning, are not new tools, but they are becoming now mainstream in cloud services. Many of these tools have changed the effort from extensive programming to configuration and adaptive models. However, complex problems will still require data scientists and programmers. There are many examples that correlate data from sensors and actuators to determine proper set points and production settings, leading to tighter specifications, less weight, reduction of fuel and power usage, etc. There are many cases that have been in the industry.
So with so much data, what's the best way to organize and make sense of it all?
Okay, when data is managed centrally, it is important to think about data transparency and the interconnectivity. For the users of the system, where the data resides, it doesn't matter, as long as they can connect with data whenever and wherever it's needed, in the right format, resolution, and detail. So having a central repository can help aggregate the data and provide the programs and the users to act on a variety and richer set of data.
I'd be remiss if I didn't ask you about cybersecurity. Is the cloud really a safe place to keep and manage data?
Well, I would say yes. Many providers disclose their cybersecurity policies and procedures. From the hardware perspective, a proper design with the use of firewalls, network segmentation, managed devices, limited access to premises and enclosure. Regarding software, antivirus and malware defense programs, data backups, encrypted data, multi-factor authentication, certificates, and a variety of methods to ensure that the data is protected and will not be accessed without proper authorization. It is important to have monitoring and active scanning for vulnerability systems, as well as performing audits.
You mentioned vulnerabilities. So how do most cybersecurity breaches occur? Is it most likely failure of hardware, software, or simply user error?
Well, it's all of the above. Breaches can occur as a result of an external attack. In many cases are composed with internal weakness, such as phishing emails, executables, attachments, and others. So basically, we can say that there are 5 pillars for cybersecurity. I can mention quickly: architecture and design, implementation, operation and incident response, governance, and attacks and threats and vulnerabilities. So any failure on any 5 pillars increase the risk of a breach. And in many companies, this system on premises are handled by IT, OT departments that must establish procedures and methods.
For an organization just trying to get into Industry 4.0, what are the best first steps for them to undergo?
Well, I would say there is a lot to consider. The best initial step will be to find a solution provider that can help you identify the opportunities for improvement in the operations and advise you in the Industry 4.0 tools and technologies that can help you get in there. Sensor vendors are everywhere, but to succeed with Industry 4.0, you really need the kind of a plan I talked about earlier, a vision of the information you need to improve your operations. The right solution provider can help you identify areas of risk that are not currently effectively monitored and understood and recommend solutions that will deliver the insights that you need to maximize uptime and informed decisions.
This has been great. Thank you for sharing your insights today, Alejandro. To learn how we're reimagining innovation by adapting digital technologies and helping manufacturers do the same, visit eaton.com/digital innovation.